In today's video, we'll be looking at the finite element analysis of a tapered bar subjected to axial tension. The topics are as follows. First is the problem definition. Then we will look at the conventional methods to solve the problem using the strength of material approach. We will look at the FEA method applied to the problem. And finally, we will look at the Ansys static structural analysis and compare the results. The problem is as follows. A tapered bar of given dimension is subject to axial tension with the material properties mentioned. The objective is to find the total deformation of the bar and deformation at the section at 50. From the fixed support, also find the stresses in the bar. The total deformation is calculated using an analytical formula. And to find the deformation in between the bars, we need to calculate the width at the required location. Since the taper is linear, the width is easily calculated. Then the same formula can be used to calculate the deformation at the required location. The stress is also calculated using analytical relations. The reaction force is found out by applying force balance to the bar in the FEA method. The taper bar is split into two equivalent stepped bars, and a problem is solved using the same method as the stepped bar. The area is calculated as shown, and the elemental matrix is written for both elements. After that, the global matrix is formed by assembling the elemental matrix. The boundary condition is imposed on the global matrix, which results in a set of linear equations. And by solving this equation, we can find the known variable and deformation at nodes 2 and 3. So the stress is found using the stress-strain relation as shown. So the reaction is found by substituting the U in equation 1. Now we move to Ansys Workbench for simulation. The first step is to drag and drop the static structure onto the project. Go to engineering data and edit the material property as per the problem definition. Now go to geometry and open design modeling. Change the unit as per convenience, go to the XY plane, and draw the rough sketch of the taper bar. Give the dimension of the taper bar. It would be the taper with dimension is asymmetric. To make it symmetric, draw a line as shown. And go to the constraint tab and select the midpoint constraint. Now select the horizontal constraint and apply it to the drawn line. The taper bar is symmetric, so we can delete the line. Go to the Create tab, select Extrude option, choose the sketch, give the extrude depth as per the thickness of the taper bar, and add frozen for the operation. To split the body, we need to create the plane. We choose YZ plane and create the new plane with offset as 50 millimeters in the required direction. And click on Generate. Go to Create and select Split option. select the newly created plane and the body to be split. Click on Generate. Select both solid objects, form a new part, and change the share topology to automatic. The geometry part is now done, and we will go to Ansys Mechanical for the analysis. The second approach is to make the sketch symmetric about the x-axis. Make the half sketch above the x-axis with dimension as shown. Similarly, make the other half below x-axis with dimension. As shown, this will result in complete geometry. Now extrude the 2D sketch and give the extrude depth as the thickness of the taper bar. To split the body at desired location. Insert new plane by choosing appropriate plane. In this case, we will choose YZ plane with offset in Z direction as seen on graphics. Click on Generate, select the slice option and choose the plane and the body to be sliced. Click on Generate to form a new part from the two solid objects and change shared topology to automatic. The importance of creating a new part and shared topology is used while creating conformal mesh, which results in same node share by both bodies. And we will go to Ansys Mechanical for the analysis. Click on Geometry and check the material assignment for both objects. Generate the default mesh. Apply the boundary condition as a fixed support and force on the geometry. Now click on Solve. After solving, insert direction deformation in the force direction for both elements. Similarly, insert the normal stress and choose the direction in which the force is acting. I evaluated the result, and for deformation, note down the maximum value. And for stress, note down the average value. To obtain the force reaction at a fixed support, while the result is displayed by default, it only shows the result for the body. To see the whole geometry, change the option just below the scale option. Now, other body is also visible. Go to Insert, Add Directional Deformation, select Face. For the Finding the U2, we will choose the interface between the two bodies. Bottom left corner of the graphics panel, we choose the required face by selecting the planes from that option. The other is hide the body and select the required face and apply. While result is shown, turn on Show All Bodies option. To obtain the force reaction at a fixed support, insert a probe, select the force reaction option, and choose Fixed Support. And then note the value. The result is tabulated. The FEA method and ANSYS result matches with the analytical result with reasonable accuracy. And then deformation at the mid-surface by analytical FEA method and ANSYS are also within the required accuracy. The result can be further improved by increasing the mesh count. In this, gravity is not considered if we assume vertical bar deflecting under gravity. What would be changes in governing equation and solution methodology? And following are the references for further reading. That's all for today's video. Thank you.